Now, for the purpose of graphing in this course, yeah, I shall recommend the use of Geogebra. So you can get this software from geogebra.org and just go ahead, use download now, and download it on your computer, specific to the computer that you are using. So typically once you have your GeoGebra installed, you can see the software appear like this, and at the moment we are going to use only these two tools. Okay, so say we would like to see, and we are going to see graphics mostly, as I said. So say you would like to see a graph of something as simple as fx equals x square. What we would do is, say when we are in GeoGebra, we will go ahead and for the input, for the input we will, just a moment, for the input we will say that this is just like x to the power 2. You press enter. Here is the function displayed for you, and here is a graph. Now, this feature would let you drag the graphing window. So I clicked on it and just pressed the the left mouse, and I could drag it in the middle. Say I want to change the scales, I can do this. Just move it around or hover it around here. When you see this double arrow, just expand it horizontally. It changes the window. Likewise on the vertical side. Or you can do this, select the function, right click, okay, and then go to object properties, and come on, object properties, here they are. And you can also do this, that is, you can change the style of the line, make it thicker if you would like, change the color and all that. Okay, all right, so here is how we can graph a function, and then you can change the scale and adjust the window. All that we will do later. Okay, so this is a simple graph here. Now let's look at a couple of other examples. Now let's say we would like to graph a piecewise defined function such as this one, which takes on values x squared if x is less than or equal to 1, and 2x minus 1 if x is greater than 1. So what we do then is that we go to GeoGebra. We can keep our original function, but if we don't need it, we can see we can select it and then just press delete. It is gone. Now remember this, our function is this piecewise defined function. So in this case I can select this option, that remember the condition was that if x is less than or equal to 1, so I will type x, and then here I go to these, this symbol tool, and just put less than or equal to 1. What was the definition? I think definition was that this is x square, and for the other region it is 2x minus 1. All right, so once you have done it, just press enter. Okay, let's see, what did I messed this up. I don't know why I put this in here. Yeah, this was not needed. So once I do that, you can see the function is defined by x squared for, I'm just keeping fonts a little large for presentation. So for x less than or equal to 1, it's defined by x squared, and beyond that it takes this straight line path, that is 2x minus 1. Now say you have a function which has more than 2 pieces, then you can go in a similar way. For example, and now say if we have more than 2 pieces of a function, for example this one, where function is defined by x squared for x less than or equal to 1, 2x minus 1 for on the open interval 1, 2, and say 3 times tangent inverse x if x is greater than or equal to 2. So the process will be quite similar. We are not going to take the else condition. We will first take the condition this, that is if x is, just a second, what did I say for the function? Okay, I forgot what I had said there. So here, if x is less than 1, or I think it was less than or equal to 1, so we will put less than or equal to in here, and then just put x square, and there you are. So this is this branch of the function, and then we have for the second part, the condition was what? That between 1 and 2, so we have 1 is less than x is less than 2. The function was defined by the line 2x minus 1. So let's bring that in, and then here we have if x is greater than or equal to 2. So here we go, come on, greater than or equal to 2, then we have what was that? I forgot again. 3 times tangent inverse x, so it is 3 tangent inverse is we input that as arctangent x. So when we do that, see here's 3 times tangent inverse of x for x greater than or equal to 2, and you can see we have a discontinuity here. All right, now let's just do one more example, then you will just enjoy it on your own. All right, now I have posted the a library of some pre-built functions in GeoGebra for you on the website. But anyways, here, say you want to define this greatest integer function. For example, you know what this greatest integer function is. If I put a number, say 2.3, the value will be 2 because it's the greatest integer that's less than or equal to the input. All right, so here the value is equal to 2. Now in GeoGebra, what it does is it just takes that as floor x. Okay, that's how you enter it in there. So let me give you the example here. If for the input, if I put simply floor x, all right, then here you go, you have the greatest integer function defined here. All right, and then you can just do the composition of this function with other functions. For instance, let's look at the relative graphs of say I have sine x. So this is your graph of sine x, and then I said floor sine x, composition of the sine function with this greatest integer function. You can see here it just gives you the composition here as you would expect. So I'll just now let you play with this on your own, okay, and hope you enjoy it.